So if you remember from geometry, you did 2-column proofs. Here's my problem I'm starting with. It says 2x over 7x squared minus 7x plus 4 over 3x squared. So I've done a 2-column proof, and I've actually on the left side, I've done the problem. But what I want us to work on is understanding why are we doing what we're doing. So in a traditional geometry 2-column proof, what was the reason in number 1? Do you remember this from last year? Have you guys not done 2-column proofs?
I don't think I remember doing any 2-column proofs.
Okay, you're supposed to do 2-column proofs in geometry. Excuse me. All right, you're going to start with the given, okay? You should have a given. And then what I want you to do is I want you to look at from the first row to the second row. What did I do? What's the only thing you noticed that I did?
You factored your GC.
I didn't, well, I factored, okay? You're going to factor the denominators. And in this case, there was only one that I needed to factor. And then from this line to this line, what did I do? Let's just look at the first fraction, okay? Look at the first fraction only. What did I do from here to here? I multiplied by 3x over 3x, correct? I didn't multiply by 3x, because you can't just multiply by 3x. But what is 3x over 3x? 1. And what's 7 times x minus 1 over 7 times x minus 1? 1. Okay. Now, you multiply by 1, but what I'm doing is I'm building a common denominator.
This is Matthew.
Yes.
Is it like the denominator? Oh, it's in each. Like, because on the other side is 7x. 7. I'm just wondering, like, why the x squared isn't on there and then the x.
Yeah.
Where?
Why use 3x instead of 3x squared?
Oh,
And then
good
not
question.
7x
Yeah, okay.
quantity x minus 1.
Okay, no, I'm not multiplying this times this and that times that. That's not what I'm doing, okay? Good question. No, okay, so then that's my question is, how did I get 3x and why isn't it 3x squared? Can anybody tell?
Because 3x times 7x would be 21x squared, and your 7 times 6 would be 21.
Okay, so if you look at these two denominators right here, you're really asking yourself what would be the common denominator. Well, 7 times 3 is 21, and out of x and x squared, I only need an x squared. I don't need an x cubed, because x squared does the job. And then I've got the x minus 1. So when I'm looking at this denominator, I have one of those x's already. So I don't need to multiply by 3x squared. Really good question. Okay, good question. And then over here, I have the 3, the x squared. I have this x in here. I only need the 7 and the x minus 1. Well, we'll go over how you get that on my notes, but for now, that's what's going on. Now, from here to here, what did I do? I just multiplied. I took 2x times 3x and got 6x squared. I took 7x times 3x and got 21x squared. Okay, how about from row 4 to row 5? I used the distributive property, so I'm going to write distribute. And I want you to use this, when this front and the back of this, as you do your homework. This is an excellent guide for us. All right, now let's slide this down. And what did I do to go from line 5 to line 6? I just added. Okay, that's it.
But if you would have distributed the denominators, you would have still had the same.
Correct. But we don't need to.
Okay.
We don't need to multiply out the denominators. You can. There's nothing wrong with that. But we could make an extra mistake if we kept going. And eventually, we're going to be factoring the numerator as well. And so then we want it to be factored so I can cancel anything. Alright, so now let's repeat. Here's my problem. This one's subtraction. So, what's my reason for the first statement? It's the given. Okay, now what did I do from line 1 to line 2?
Factor denominator.
Factor the denominator. Okay, from line 2 to line 3, what have I done? Multiply by 1. And the reason why you're multiplying by 1 is it's building the common denominator. So now let's pause here a moment because we do want to help ourselves. Do you see there's a 3, so that's what was missing. They both have an x minus 2. I don't need x minus 2 squared because x minus 2 takes care of both of them. And then I need the x minus 1.
Okay.
Does that make a little bit more sense?
Yeah,
Okay.
a little bit easier.
Okay, good. And don't worry because we're going to do like 10 more of these
Okay.
in class. Don't worry. All right, number 4. What did I do from line 3 to line 4?
You multiply.
You just multiply. Good. Now, I would like you to put a big giant star here between 4 and 5 because the only difference between problem 1 and problem 2 here is I added on the first one and now I'm subtracting. But here's the deal. This is FOIL, right? X plus 3 times x minus 1 is FOIL. And I need to subtract everything out of that FOIL, not just the x squared. So I need you to notice that we have to put a bracket here, and I'm going to end up after I figure out the FOIL, like I can't do that all at once. I need to first do the FOIL, and then I'm going to distribute. So from step 4 to 5, I'm still multiplying or doing FOIL. All right, then between 5 and 6, what's happening here? Okay, we just distributed the minus sign. And once you do this, I think it really helps when you're writing the reason, like why are you allowed to do it? Then when we start doing stuff you can't do, you realize, oh, I don't have anything that lets me do that, so then you kind of catch yourself. All right, then from 6 to 7, what did we do? Add like terms. Sometimes you can write combine like terms. That's the same thing. Okay, now what did I do from line 7 to line 8? Factor out the negative. Do you remember when we factored in chapter 4 and chapter 5? I told you if the leading term is negative, we factor out the negative.
Ooh, I see what you did.
Okay, now what did I do? I factored the numerator. And final step, what did we do? How did we simplify? Cancel common factors. Cancel common factors. You're absolutely right. We did simplify. We did reduce. But we call that cancel common factors. Can I cancel the 6 and the 3 though? No, because that 6 is in a term right there.
This isn't so
No, it's not so bad. Well, it'll get a little challenging here, but let's go ahead and look at my notes. And we're going to start off super easy and build up steam. What if you have like denominators? For the most part, this is pretty easy. This just becomes 7 plus 3 over the common denominator. We reduce all fractions. So that's 5 over 2x. In example 2, this is 2x minus 5 over x plus 6. I cannot cancel the x's because they're terms. Please put a star next to example 3. If you subtract and there's more than one term, you need to insert a grouping symbol. So this is x plus 3 minus 2x minus 1. So that's negative x plus 2 over x plus 5. Okay? Be careful. Because the most common mistake I see on quizzes, and there is going to be a subtraction problem, and you're going to have to pay attention to this. You can't say minus 2x plus 1, because then you didn't subtract the numerator. You only subtracted the first term. One other thing I want to point out is if you go to check your answer in the back of the book, and the textbook wrote 2 minus x over x plus 5, do you understand those are equal? And you mark it correctly. Sometimes math textbooks like the first term to stay positive, so if they can switch it to make the first one positive, they will. You don't have to do that. We should have enough confidence to know those are equal answers. Okay? All right, now what we're going to do is we're going to do a whole bunch of these where we practice getting the common denominator, okay? We're going to call it LCD, not LCM. And what's really, really kind of neat is if you remember back to elementary school, maybe 3rd grade, 4th grade, and you were doing, okay, I want to add 1/2 plus 2/3, you had to learn how to get a common denominator, right? Okay, well, it's the same concept. You laid the foundation earlier in elementary school, and now we're going to apply it to a lot more complicated stuff. All right, so here's what you do with an LCD. You do the numbers, and then you do your letters. Okay, and you don't do the numbers and letters the same way. 5 and 6, that'll be a 30, and they both have an x. We don't need x squared. In example 5, 3 and 4 will be 12, and then there's an x and an x squared. On the variable, you take the higher exponent. Okay? Now, in example 6, sometimes you need to factor before you can find the LCD. They both have an x plus 3, but there's also an x minus 3. So the LCD is x plus 3 times x minus 3. In example 7, I need to factor. So this is a GCF of 4, and then I get 4 times x plus 2, x minus 2. Then this is a perfect square trinomial. Now there's a 4 and a 6, and I don't mean to have misled you. You do not always multiply the two numbers. It's not 24. What's the?
12.
It's 12. If you're like, well, wait a minute, how do you get 12? Here's a trick, a little number trick. You can take 4 times 6, but if they have a common factor, you have to divide by the common factor. The common factor is 2. So 4 times 6 is 24, divided by 2 is 12. These had no common factors, okay? So like, here's a cool one. What if I had 6 and 8? You could take 6 times 8 is 48. The common factor is 2, so it's 24. That works with all numbers, okay? All right, so now to get my letters, it's x plus 2 and x minus 2 squared. Do you guys see that? All right, I want you to try example 8 and 9. I'll give you a head start. And while you're doing that, I left something on the board from the earlier class. I know I mentioned my kids. And my one son's in physics in college, and one of the formulas he's working with has to do with lenses, like, eyeglass lenses and other kinds of lenses. And they have a formula they're working with that if it's 1 over the distance to the object plus 1 over the distance of the image, if it's like in a mirror perhaps, or where you're looking, equals 1 over the focal point. Well, that's a rational equation. So I wanted to show, I was like, oh, I'm writing that down. Let me take it to school with me. I said, we're working with rational expressions. In 8.6, we're going to do rational equations. So you're trying to find the focal point that is the best, where you can get the best lens, where you can get the distance of the object, distance of the image to be where you want it to be. So very, very neat stuff. Oops, that's not a 4. Kidding. 6x plus 9.
We were just trying to see if we were paying attention.
Yeah, but no, we're not even going to pretend. All right, 5 and 4, that'll be a 20. They both have x plus 3, but there's a square. So check that one. All right, the LCD in example 9, they both have an x plus 7, and then there's also a factor of x minus 2. Do you now feel better about LCD? Okay, I knew you would after we did all those. All right, now we're ready to figure out how to do this with unlike. I gave you the 2 examples, but we'll work through lots of these, okay? Step 1, find the LCD. Step 2, build equivalent fractions with the LCD as the denominator. That's the step we were multiplying by 1, okay? And then it says add or subtract. So the first thing you have to do is you need to factor each denominator. And so when you look at my guide with the steps, this should really help. So who would like to attempt to identify the LCD? Anybody want to try it? Noah, what do you think?
3x one of them?
No?
No, I don't.
Elena?
9x squared x plus 1.
Yes. Okay, you look at the 3 and the 9. It's 9. You have an x and an x squared, so you need the x squared, and there's an x plus 1. Okay? Then what you do, so you determine the LCD, and then you're going to end up multiplying by 1, but you need to ask yourself this question: what's missing in that first denominator? What do I need to multiply 9x squared by that gives me the LCD? So McKenna, what would I need to multiply by here?
X plus 1.
Good. And I'm going to multiply x plus 1 over x plus 1. All right, then Andrew, what do I need to multiply the second denominator by? The 3x times x plus 1. What do I need to multiply it by that creates the LCD?
I don't know.
Henry?
3x.
3x. Do you see I already have the x plus 1, and you're coming back over here to the LCD. I've got an x plus 1, and I have a 3x, but I need to get a 9x squared. Okay? So you're asking yourself what's missing. So here we go. Now, let's try to, and you guys, on your homework, tonight and in the future, go down your page. Do not go across. This is going to take a lot of space. So prepare yourself for lots of paper, okay, in your future. So watch what I'm going to do. I'm going to need to take 7 times x plus 1 plus, and I'm going to take the x times 3x, but the denominators are the same, right? So we're going to put it over the common denominator. I do not recommend starting the distributive property early because when we get to the subtraction, you'll get into trouble with forgetting to distribute the minus. So let's do it this way, nice and slowly. So this is 7x plus 7 plus 3x squared over the common denominator. And then we typically write these in descending order. and that's my answer. Alright, let's try another one. The first thing you want to do is factor each denominator so we can find the LCD. Alright, so Hannah, what's the LCD on this one?
It's gonna be 10x squared, and then in parentheses x minus 2.
Good. 10x squared times an x minus 2. Now we need to multiply by 1 that's going to build the common denominator. So Megan, with my first one, what do I need to multiply 10x squared by that completes the LCD?
X plus 1.
X plus 1? There's no x plus 1 in the LCD.
Oh.
Are you on the same one we are? We're over here. Like I have the 10x squared. What's the only thing missing now?
X minus 2.
Yeah, there you go. I think you were looking at the other example. There we go. Okay, so now, Jaslyn, what do I need to multiply this fraction by, the second one, that completes the LCD?
5x.
Not 5x. 5x,
2x.
2x. Yeah, I think you were adding. Yeah, you were adding there. Okay, so now watch what we're going to do. This is multiplication. So I'm going to take 3 times x minus 2 plus 2x times 2x. And you guys understand that we built the common denominator. Now I'm just going to distribute. I get 3x minus 6 plus 4x squared over the common denominator. And then I'll just tidy that up. Can I cancel the 4 and the 10? Why not? Okay, the 4x squared is a term. The 10x squared is a factor. That's why it's a little bit tempting to do, but you can't do that. Alright, let's keep going. Now we're ready to work on subtraction. So in example 12, I'm going to start by factoring the first denominator because the second one doesn't factor. Okay? So then Carmel, what's my LCD on this one?
X minus 2.
Say it again.
X minus 2.
Nope. Because I've also got an x plus, it's got to include everything in the denominators, right? So it's got to be x minus 2 times x plus 2. It needs to have both factors. So it's any factor that you see, but if it appears on more than one, you take the higher exponent.
Okay.
Now if they both are to the first, you just take it to the first. Alright, so now you should notice the first fraction has the LCD, so I don't need to do anything to that one. Okay? Alright, now Andrew, try this one again for me. In the second fraction, I have an x minus 2. What factor is missing from the LCD? Here's the LCD, okay? You need to be over here. What factor is missing?
X plus 2.
Yes, that's it, okay? Now here's what I was referring to. I know some of you might have wanted to jump ahead of me in your steps, and I'm really cautioning against it, because watch what you're going to do here. You're going to take the first numerator minus, it's 15 times the quantity x plus 2 over the common denominator. Now I'm going to distribute the minus sign. This is where I won't make a mistake then. So I get x plus 4 minus 15x minus 30. And then I'm going to combine my like terms. I get negative 14x minus 26. You should notice at this point that the numerator has a GCF, doesn't it? So I should attempt to factor it. And I'm actually, the first term's negative, so I'm going to pull out a negative 2, and I get 7x plus 13. and unfortunately nothing cancels. But if that numerator factors, and we're going to see that here in a little bit, where we can do some canceling. Okay, all right, here we go. Example 13. We're going to factor out the GCF, and I'm going to factor this denominator as x minus 5, x plus 1. So remember, step 1, factor each denominator. Step 2, find the LCD. So McKenna, what's the LCD here?
3x minus 5 times x plus 1.
Good. You guys don't lose the 3. 3 is a factor in the denominator, so it's got to be used. So then, Noah, what am I going to multiply the first fraction by to complete the LCD?
X plus 1.
Good. You need an x plus 1. And then, Hannah, what do I need to multiply the second fraction by that would complete the LCD? 3. Now, you guys, when you're telling me x plus 1 and you're telling me 3, you are making it 3 over 3 and x plus 1 over x plus 1. Because you're allowed to multiply by 1. Alright, now watch this, guys. I'm going to do something fancy here. Not too terribly, but watch. 2x minus 2 times 3. I can use the commutative property and put the, don't we usually put a single term in front of a double? Yeah, we usually do that. So anytime I have that, I'm going to take the liberty of using the commutative property and switching that order. Not a problem. So then this is x squared plus x minus 6x plus 6 over the LCD. Again, look at that handout I started with today. As you're doing these and you get stuck sometimes, and ask yourself, did I factor the denominators? Did I get the LCD? Did I multiply by 1? Did I multiply? Did I combine like terms? You know, what did I do? So I'm getting x squared minus 5x plus 6. Now I'm looking at the numerator. That looks like it factors, doesn't it? That's x minus 3, x minus 2. Bummer, that doesn't help me any. But at least it factored. Okay? Alright, how are we doing? It's pretty tough. Tough stuff. Alright, try example 14 on your own. I'm going to give you a head start this time. Okay, try 14. See if you can go the whole way. Did you already do it, Henry? Remember the technique I showed you on the previous example. Put this 2 in front, okay? Otherwise, you might make a mistake. Alright, now try to see if that numerator is going to factor. It does. And I've got a common factor that's going to cancel this time, which we hadn't seen quite yet. So your final answer should be x plus 4 over 2 times x minus 3.